All right, guys, there is number one. Number one was a tan equation, so you actually will only be doing that first quadrant. I don't know if you guys remember that. If you did quadrant 3 as well, it's fine. But you don't have to do quadrant 3 like we discussed. Okay, so you take the -3 over, it becomes +3. Then you divide by 5. So you have to get to this point before you find your reference angle. Okay, you need the trig ratio and angle equal to a number. The reference angle in this case was 30.96 degrees, and because it's where tan is positive, we would normally work in quadrants 1 and 3. Just hold on quickly. But since quadrant 3 would be a repetition of this general solution, we only have to state quadrant 1. Yes.
Can we write reference angles on? Yeah, we can.
Okay, I'll move up so that you can see number 2 as well. There we go. And number 2, you had to first get sine x on its own. So if you move this +1 over, it will become -1. So you have -1 minus 1, which is -2. Then you divide by 3. So now you'll say, where is sine negative in quadrants 3 and 4? So you find your reference angle. Then for quadrant 3, you do 180 plus that angle. For quadrant 4, 360 minus that angle. You can just ignore the stuff in red at the bottom. You weren't supposed to do that. How are these guys? Were you able to do them? Okay, number 6. I just want to get something here. Okay, number 6 was that one that looked very complicated. Okay, so where you had cos 71 and sine 17, which, like we discussed yesterday, are actually just numbers. So what I did was I just moved that plus cos 71 over, and then I typed all of that into my calculator, and I got that number. I can't remember. I think this was rounded, right? So you then had to work with the unrounded value, obviously, in the calculator. So for your reference angle, you're going to do shift cos. Remember, guys, important for the reference angle, you ignore the minus. Okay, so you type in shift cos of the value, excluding that minus there. We bring the minus into account when we work in the negative quadrants. Okay, so we're not leaving it out. We're just not using it to get that acute angle. So where's cos negative in quadrants 2 and 3? So for quadrant 2, you're going to do 180 minus the reference angle. For quadrant 3, you do 180 plus the reference angle. And you would have to work with the unrounded values, but it did actually equal these ones in the end, yes? Only around the final. Any other questions on those 3, guys? We're going to do number 10 of that exercise together quickly. So you can just carry on underneath that. We'll do number 10 together. Number 2. Number 10. We're going to do number 10 now, yeah? All right, number 10 was cos 2x is equal to negative 0.123. That was the question in number 10. Oh, sorry. So guys, do we see that we have the same scenario? We have a trig ratio with an angle equal to a number. The only thing that's different here is that the angle obviously is more complicated, right? The ones that we've done so far, it's just been x. Now the angle is 2x. But that's not actually going to change our method, guys. Do we have a trig ratio equal to a number? Yes, hey, we have cos of an angle. It doesn't actually matter what that angle is. We'll sort that out later. We have cos of an angle equal to a number. Where is cos negative? Cos negative 2 and 3. We're going to find our reference angle by saying shift cos. Remember, for the reference angle, we ignore the minus. We don't use the minus for our reference angle. So we're going to do 0, 1, 2, 3. Shift cos 0, 1, 2, 3. We get 82.93. I'm just going to leave that in the calculator, obviously, but that is the reference angle. Now we're going to do a quadrant 2 solution. But guys, what is my angle now? Is my angle x like in the previous ones? It's now 2x. So now when we set up our general solution, we have to say 2x is equal to, right? Because when we do shift cos, we basically are separating the cos from the angle. But now the angle is 2x. So that is what we have to use in our general solution. Okay, that's very important. What do we do in quadrant 2? 180 minus, oh, why am I thinking plus? Sorry, 180 minus the reference angle, which is 82.93 degrees. Immediately, guys, plus 360n. Yes. We are going to do it, but only in the next step. Well, you will have to, we'll see now that it will give you different ones, but we're going to do that next. Okay, first we just set up our normal, what's it called, general solution using 2x, 180 minus plus 360n. We need to tell the marker what n represents, right? N are all integers, or n represents all integers. Now you can just calculate that, yes? No, so if it's in a test and there are multiple equations, you just have to write it the first time. Yes, yeah. You just have to write it once for the whole test. Okay, guys, I just saved this as A quickly because I'm going to have to use it for 180 minus and 180 plus. So 180 minus A is that. Okay, I'm just going to write that quickly. 97.07 basically, plus 360n. But we have to solve for x, right? What we have here is 2x. So now I'm going to have to divide every single term by 2, including the 360n. Okay, that's very important. So now I'm going to say this value divided by 2 is 48.53. Now we can round that off, right? That's now the final answer for our quadrant 2 solution. So we're going to say x is 48.53 degrees plus 180 n. So guys, this should make sense to you because if we think of the graph of y equals cos 2x, if you had to draw that graph, what does the 2 do to the graph actually? The number in front of x. It changes the period. Do you guys remember? If your x in your graph equation has a variable, we call that k. All right, so if it has a number in front of x, then you're going to take your normal period divided by that number. So if we were to actually draw this graph, y equals cos 2x, it would have a period of 180 degrees. So this point would come up every 180 degrees, not every 360. Okay, you don't have to remember that in order to do this equation, but you must please, as soon as you're saying 2x is equal to this, you have to add your 360n immediately. Okay, it's a very common mistake that people want to calculate this, then divide by 2, and only then add the 360n, then you're going to get it wrong. Okay, as soon as you're writing your quadrant 2 solution, you have to do plus 360n immediately. Okay, that is the one solution. We still have to do one for quadrant 3. Again, the angle was 2x. We have to write 2x. Quadrant 3, we do 180 plus that reference angle, which I saved as A in the calculator. So I'm going to use that again. Immediately, I do my plus 360 in. Just going to calculate that quickly. 180 plus A. That is 262. Now, because it's 2x, we have to divide everything by 2. So we're going to say x is equal to, divided by 2, 131,47 degrees plus 180 n. Any questions, guys? Looking for this exercise quickly. I want us to look at, on that exercise number 4. I'm not going to do it with you. You guys are going to do it for homework. But number 4. We'll leave number 3 for now. Okay, we'll leave that one out for now. If we're looking at number 4, do we see that we now have a complicated angle there? Right? The angle is x minus 22 degrees. But do you see that we have a trig ratio and an angle? Right? It's sine and an angle. Like I said, it doesn't actually matter what that angle is. As soon as you have your trig ratio with an angle next to it, you're going to do shift sine of a half. Okay, then you're going to get, instead of 2x, what we had here, you're going to write the whole angle, which is x minus 22 equals your blah, 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 plus 360n. Then what's the opposite of minus and 22? If you then have to move it, you're going to add 22 to the other side. Yes, to your general solution, yeah. Okay, guys, you're going to do 4, 5, and 8 for tomorrow. Yes? Yes, yeah. So it's almost like you're working with not with unlike terms. So it will be whatever your degree is plus 22. Guys, let's just talk about number 8 quickly. In number 8, we see that our angle is x plus 50, but do we see that it's not written properly here? We don't have a trig ratio equal to a number. Okay, I need to just have tan of x plus 50 equal to a number. So for this one, you're going to have to move that plus 1 over. It's going to become minus 1. And then what's the opposite of dividing by 3? Then you're going to times by 3. Then you're going to have tan x plus 50 equal to a number. Then you can do shift tan. Okay, so you always have to have it like it's written here. A trig ratio with an angle equal to a number. Okay, even if that angle has multiple terms like we see here, or if the angle is a double angle, we call it, if it's a 2x or a 3x or an x over 2, you're not going to mess with that angle before you do your general solution. Okay, only in your general solution do you start moving things away from the actual angle. All right, let's get going, guys. Yes. Or you'll plus 22 from the end. At the end. Yes. Yeah. So to your general solution, you're going to add 22. Yes, exactly.